today I'm going to tell you guys what the fourth dimension is like. So, we're going to start off by reviewing what other dimensions are, which you probably already know. So, a simple dot on a flat plane would basically be zero-dimensional because there's no dimensions for this thing. Like, there's no length, there's no height, there's no width, there's nothing. And there's no axis. But then if we extend this to infinity, then you get a one-dimensional figure, which you could call a line. So this is 1D, because it only has one dimension, which is, I think, length. So it's only got an x-axis. And then what if you make it 2D? Well, that is when you extend this to infinity and you stack them up, and then you eventually end up with a square. Now it has a y-axis. Then if you extend this to infinity, then you get a cube. Now it's 3D, and it has a z-axis. But what comes after that? Well, after that, after the cube comes a tesseract. And it's pretty much impossible for me to draw this, because there has been several people that have visualized tesseracts on a screen, like, as they're rotating, but if you try to picture a tesseract in your head, you couldn't do that, because you live in a three-dimensional world. So, there is literally nothing I can do about it. But as I said before, like 30 seconds ago, there have been some 3D visualizations of a tesseract. Like, I'll play you one right now. Like, here's one. As you can see, it's rotating as if it were in a three-dimensional space. It looks pretty weird here because we're not in a four-dimensional world. And four-dimensional objects have a w-axis. Like, here's it rotating from the xy axis. Here's one of them rotating from the xw axis. Here's yw. Here's zw. And when it's rotating on the w-axis and anything else containing the w-axis, it looks pretty weird. It's because we're not in a four-dimensional world. But what if you did live in a four-dimensional world? Or what if you were surrounded by a four-dimensional being? Well, if you tried, like if your friend was four-dimensional and they tried to give you and you tried to give them a birthday present or some other Christmas present or something like that, then they could see what's inside that Christmas present, because the three-dimensional space appears flat to them. Because you know how a square is flat, right? That means that a three-dimensional cube would basically appear flat to a 4D observer. Because to a 2D observer, you would look at this line as flat. So 3D objects appear flat in the 4D world. So don't try to surprise your 4D friend, or else they could see what's inside the present you're giving them. And what can 4D objects do to you? Well, say you have a square like this, or maybe that's a rectangle, but wait, squares are rectangles, I just realized. But I knew they were rectangles from the beginning. But anyway, I'm getting off track. So anyway, let's take this irregular square, or simply an oblong rectangle, and for a two-dimensional person, you could not you couldn't flip this around, and you can't flip it around like this. Well, guess what? We actually can. So, like, say this whiteboard was two-dimensional. If a 2D person tried to flip this way, they couldn't do that because there's not a width. But I can because I'm three-dimensional, so there you go. A 2D person could not do that. So this is why if I have another shape on here, like I'm going to draw another shape on here. So I'm going to take this triangle for comparison. I couldn't turn that to make it mirrored, obviously, but if I was four-dimensional, then I could certainly do that. I could certainly take this triangle and flip it to make it look mirrored. You couldn't do that if you were three-dimensional. And if the first dimension is length, the second is height, and the third is width, then what is the fourth? Well, many people say that the fourth dimension is time, which may sound reasonable, but but it really wouldn't make any sense, because time is present in all dimensions. And if the fourth dimension was time, then it would basically be very different, and you can't physically measure time like in space, because space and time are different things. Like, time is not a physical thing, but space basically is. And because space and time are different things, then if the fourth dimension was time, then it would be very special, and it would not follow the same trends as the other dimensions do. So the pattern would be ruined. And there's not just a fourth dimension, there's also a fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, and etc. dimensions. Like, if you extend a tesseract to 5 dimensions, then you get a pentaract. And pentaracts can get to hexaracts if you go to 6 dimensions, and then it goes on forever. There's even a 9,133rd dimension. And theoretically, there's an infinite number of dimensions. But the one we should worry about now is 4 dimensions. And several other representations of 4D exist. Like, the movie Interstellar has one of the best representations of the 4th dimension. And they spend years making that movie as scientifically accurate as possible. It's a good movie. You should watch it if you are interested in learning more about space. And there's also a kid my age that made a video in 2010 about the 4th dimension. And the video link, the link to his video is in the video description. If you guys want to watch it, then feel free to. He also knows how to explain the 4th dimension. So there you go. This is proof that he's not the only high school student that can explain the 4th dimension.